Welcome back. We're in lesson 102. We're talking about sums of functions. Recall that functional notation has several advantages. The first is that it allows us to identify the equations being considered. For instance, if we have these three equations here, they all start with the same y equals, and unless we read the whole thing out, we don't know which one is which. We first, second, or third. But if we give them a name, if I were to say h of x, right? And let's say I called this let's call this j of x, and we'll call this one g of x. Well, now I have a way to, refer to them. I could say the function h of x, the function g of x, the function j of x, without having to read the entire equation in order for you to know which one I am talking about. Now, these notations in themselves do not completely define the function, for the domain must be specified or implied for every function. So let's just specify something here. I'm just going to come up with a domain. Let's say this one is reals. Let's say that this one is just going to be integers. And this third one, let's make it negative integers. So negative integers. If we want, we can add two of these equations and we get an equation for the sum. So let's add h and g together. I can just write them over the top of one another. I'm sorry, this is 2x squared. And I can add those together just like I normally would. So h of x plus g of x equals 2x squared. I'm going to just write it in descending order. Plus x plus 8, because 3 and 5 are 8. So I can also make this a little bit more succinct. Remember when we would do those factoring of the grouped items? We can do the same thing here. We can say h plus g times x. So h and g of x is equal to 2x squared plus x plus 8. So if I say h and g of x, or h plus g of x, then I know which function I am referring to. I'm referring to the addition of these two functions together. So let's jump into a problem. Let's do example 1. Let me clear the page. Alright, so example 1. 102.1. Given that h of x equals x plus 3 in the domain of the reals and j of x equals x squared minus 6 in the domain of integers, find h plus j of 2. So here's what we'll do first. We'll add these together. I have h of x is equal to x plus 3. And I have j of x is equal to x squared minus 6. So I have h plus j of x is equal to x squared plus x plus, no, that would be minus, because the 6 is bigger, so minus 3. Now I'm going to substitute in the x for the 2. You put that right in here. So now I'm just going to use my buckets like I always do. This would be 2 squared plus 2 minus 3. So that would be h plus j of 2 would equal to 4 plus 2 minus 3. So that'd be 6 minus 3. So h plus j, looks like an n for just a second, is equal to 3. Now, there's another way we could do that. We could easily say h of 2 and j of 2. And then we could say it's x plus 3, so it'd be 2 plus 3 would be 5. And then x squared minus 6. This would be 4 minus 6 equals negative 2. It'll be a 3. Same answer both ways. So it just depends on which way you want to do it. But because the answer falls within both the reals and the integers domains, we are good to go. All right, let's look at example 102.2. I'm going to erase this and put the next one up. All right, here is example 102.2. So let's walk through it. Given h of x is equal to x plus 3 in the domain of the reals, and g of x is equal to 2x squared plus 5 in the domain of negative integers, find h plus g of 5. So let's look at that. So let's do it the other way first. So we're going to say h of 5 is equal to 5 plus 3. That equals 8. And g of 5 equals to, if we have x squared, that's going to be 2 and 5 squared plus 5. So that's going to be 25 times 2 is 50 plus 5 is 55. So when we add those two together, we get 63. All right, so there's one answer, one way to do it. Let's try this way. H of x is equal to x plus 3, and g of x is equal to 2x squared plus 5. I get h plus g of x is equal to 2x squared plus x plus 8. So if I do, this is a 5, h plus g of 5 is the same thing. I have 5 times 5 is 25 times 2, that's 50, plus 5 plus 8, which equals 63. However, we cannot use this equation to find h plus g of 5 because 5 is not a member of the domain of g of x. So 5 is not a member of the domain of h plus g of x. So even though we found an answer and we're able to solve it, it's not a negative integer. So it's not going to be part of the solution. So thus, for that reason, we say the answer is a null set. Right? So this will be what you put in because it meets the conditions here, but it does not meet the conditions there. All right, 5 is not a negative integer, so it does not give us a solution that we need. We need the integer to fall into both categories. We need the answer to fall into both categories. All right, so let's look at products of functions. Now that we have talked about sums of functions, products of functions are going to be, drum roll, that's right, multiplication. Please excuse the drum roll. I thought I was being sassy there. All right, so when we multiply two functions, the product is also a function. So if we have these same functions that we had earlier, x plus 3, and g of x, x squared minus 6, with the same domains. The domain here is the reals, and the domain here is negative integers, right? Same domain that we had originally. We can multiply these together. And we're going to do what we normally do. We can use the distribution or we can use the stacking method. Whichever one you want to use works well. But we're going to write it differently. We're going to say h times x times g times x, and that's going to equal x plus 3 times x squared minus 6. You can also do stacking for this. If this is easier, you could do the stacking over to the side. X plus 3 and x squared minus 6. Negative 3 times, or negative 6 times positive 3 is going to be a negative 18. It's going to be a negative 6x. That's going to be a positive 3x squared. And then that is going to be an x cubed. So we have x cubed plus 3x squared minus 6x minus 18 for our answer. So h, how is this written? H of x, g of x is just written this way. We write the answer here, x cubed plus 3x squared minus 6x minus 18. Instead of writing h of x, g of x to designate the product of the two functions, we find it convenient to again group these since we're multiplying each one of these by x independently. We could say hg of x instead of this. So let me rewrite that right there. I'm just going to move this up. There we go. So that is how we can write that. The notation hg means that the h equation has been multiplied by the g equation in the same way that h plus g was times x in the first equation. So let's try an example problem. Alright, in 102.3, our problem says find hg of negative 4, where h of x is equal to x plus 3 in the domain of reals, and g of x is equal to x squared minus 6 in the domain of negative integers. So, first of all, let's look at this. Does this fall into the reals? It does. Does it fall into negative integers? It does. So we can actually use this to solve and have a real solution. Alright, so let's multiply them together. So h g of negative 4, that's a 4, would equal negative 4 plus 3 times negative 4 squared minus 6. So we can solve it like that pretty easily. Hg of negative 4 is equal to negative 1, and negative 4 times negative 4 is going to be 16 minus 6, that would be 10. So Hg of negative 4 is equal to negative 10. So that gives us an answer that falls within both domains. But we could do this the other way. We could also say h of x, or I'm sorry, hg of x equals x plus 3 times x squared minus 6. Hg of negative 4 is equal to, and we do the math on here, we get x times x squared is x cubed. X times, or 3x, 3 times x squared is going to be positive 3x squared. X times negative 6 is negative 6x, and positive 3 times negative 6 is a negative 18. So if we said Hg was negative 4 times negative 4 times negative 4 is going to be negative 64. And x squared is 16 times 3 is going to be 48. And that's going to be negative 6 times a negative 4, so it's a positive 24, minus 18. And if we add all those together, Hg of negative 4 is still equal to negative 10. So it doesn't matter which way you do it, you're going to get the same answer. I would look at it and especially if you have a situation like this, I would just solve it the easy way. Go ahead and do the answers and then multiply. But you can see that when we have variables, those variables do indeed retain the value, and it does make sense regardless of which way you do them. Let's do one more. Let's do 102.4. All right, so this says to find f of g negative 4, where f of x is equal to x plus 3 in the domain of reals, and g of x is equal to x minus 6 in the domain of positive integers. But we have a negative integer. So therefore, we are not going to be able to solve this problem because we have a negative integer here. Now, it is entirely possible that we could potentially get a positive integer, but I don't think so. It says we cannot use this function to find f of g negative 4 because negative 4 is not a member of the domain of g of x. So it's not a member of the domain of f of g of x. So we can say this problem has no answer. We don't even have to solve it. We just say it is one of these, or we could say null set. Right? All right, that's all we have for lesson 102. I'll see you in lesson 103.